All right, y'all, we're going to take a quick look at question 5 for our recitation 7. And this one is the electric flux through the closed surface whose cross-section is shown below. So here's our cross-section, and since we see that it's given that it's this closed surface, right, that's when we can definitely use Gauss's law, which gives us that the flux is equal to the enclosed charge divided by this epsilon naught, right? So the key point here is that it's this enclosed charge that we're looking at. So it doesn't matter what this one's doing out here. The only thing we're looking at is this enclosed charge. Because again, like what we were talking about with one of the other questions, if there's this charge out here, this is going this way, all these field lines, it's going to go into the surface, but it's going to continue and then go out of the surface again. So the net effect of this outside charge is going to be 0. But if we look on the inside, they're just going straight to the outside. So that's going to be where our actual effect is. And that's what we're looking at for Gauss's law. So our charge of our enclosed point charge is 3 times 10 to the negative 8th coulombs. And that's going to be divided by, that's our charge, our enclosed charge, and that's going to be divided by this epsilon naught, which is 8.85 times 10 to the negative 12th. And if you divide all that out, you're going to get 3.389830508 times 10 to the third. And that's going to round to 3.39 times 10 to the third. And since, again, we're looking at the flux, that's going to be in newtons meters squared per coulomb. And that's our answer right there, 3.39 times 10 to the third newtons meters squared per coulomb. All right, thank you all again so very much for watching. Let me know if you had any questions about this one or if there's anything else you wanted to see worked out. And I will I'll do my best to explain it because Sydney explains stuff, I guess.